Welcome to Red in Motion from the American Journal of Respiratory Cell and Molecular Biology. Increased lung permeability is a hallmark of the acute respiratory distress syndrome. The pulmonary endothelial glycocalyx, a carbohydrate-rich layer lining the cell surface, contributes to numerous processes that maintain capillary barrier integrity. In contrast, little is known about the pulmonary epithelial glycocalyx and if its shedding during direct lung injury contributes to increased lung permeability. In a recent study, Haeger and colleagues used both murine systems and human samples to determine that heparan sulfate is a critical component of the pulmonary epithelial glycocalyx, contributing to maintenance of the epithelial barrier. Moreover, they found that direct lung injury induces degradation and shedding of heparan sulfate, which is sufficient to increase lung permeability. Their paper appears in the September 2018 issue of the Red Journal. The authors first used immunofluorescence and mass spectrometry to identify heparan sulfate within the pulmonary epithelial glycocalyx and determined that degrading heparan sulfate increases lung permeability. Clinical samples revealed that airspace heparan sulfate in patients with acute respiratory distress syndrome correlated with clinical markers of alveolar permeability. These findings were also reproduced in a mouse model of acute lung injury, intratracheal administration of lipopolysaccharide. In summary, these results implicate pulmonary epithelial heparan sulfate in maintaining barrier function and open avenues for further basic translational and clinical studies of the pulmonary epithelial glycocalyx in acute lung injury. Thanks for viewing this installment of Red in Motion. For more information, Haeger and colleagues' paper, Epithelial Heparan Sulfate Contributes to Alveolar Barrier Function and is Shed During Lung Injury, can be found in the September 2018 issue of the American Journal of Respiratory Cell and Molecular Biology.